No.
Started? Okay. Now in the earlier session we discussed differentiation. Now let's have a short recap. What will be for sine of x square plus 4x plus 8? What it will be now? No, not that one. I need to write the derivative. Derivative of this. That is just a function. Now derivative of this one. Cos of, not differentiation directly. First you need to copy that as it is. So it is x square plus 4x plus 8 into 2x plus 4 plus 0. Now I would like to stress here about this part. When a variable comes along with a constant, that variable will be written, constant will be written, and the derivative of that x is 1. But when a pure constant appears, the derivative becomes 0. So in the next step I will write it as cos of, better it is to express that function in the beginning, so that it will not give the feeling that cos is for this too. So what should we write it now? 2x plus 4 times of cos of x square plus 4x plus 8. Once again I stress, this part derivative is like this, that this concept I will use in the partial differentiation concept. At that time when I refer this particular concept, you please try to answer it properly. So is this okay? So this is already discussed in the previous session of differentiation. Now let us talk about partial differentiation. For example, f is a function depending on two variables. First let me just have a touch of single variable. What is the meaning of derivative of this f with respect to x? What do you mean to say here? What is this actually? It is a measure of measure. This derivative is a measure of change in f when x changes. F depends on x. So when x changes, definitely there will be a change in f. So the measure of the change in that f with respect to change in x is derivative of f with respect to x. For example, f depends on two things, x and y. If I write what is df by dx, if I write like that, it is not proper, because this says that what is the change in f when x is changing. It is quite easily understood that when x or y, any one changes or both changes, in all the cases means only x changes, only y changes, both x and y change. In all those three situations, f will change. So if I write like this, it's not clear, because what do you mean to say here? Change in f with respect to x. What about y? Nothing is mentioned here. So writing like this is meaningless or incomplete. So what should I write? There should be a separate different notation of writing. So we avoid this notation and we use this notation. What we mean to say here? Measure of change in f when only x is changing. Only x is changing. This x is discussed means only that x is changing. So what about y? Y is treated that it is not changing. Suppose there are two knobs of input, as you have in the case of bass and treble in the case of sound systems. So how the output is changing when bass changes, and how the output is changing when treble changes. So to see the clear relation, you need to keep one constant and change another one. It's not that you are changing both of these things at the same time. You can't make a proper adjustment. So what is the change in f when only x is changing? Only x is changing means y is constant. So even if it is a function of four variables here, this stands the same. What is the meaning of this one? Change in f, measure of change in f, but simply we pronounce partial derivative of f with respect to x. When x only is changing, y, z, t They are all constants. For example, I have the function like x cube plus xy square plus y cube plus zt. If I have this function, what I mean to now calculate dou f by dou x. What is the assumption made while writing this notation? X is changing or only x is changing? Only x changes. Because we discuss only one variable here, it is understood all other remaining variables, whatever are discussed there, they will be treated as constants. So, what will be dou f by dou x now? It's a pure function of x. The partial derivative or the ordinary derivative, that is one and the same. So, the derivative for x cube is very good, 3x square plus. Now, it is xy square. Y square purely is a constant because y is treated constant. So, y square is like just a number. Earlier I said 4x. So, 4 is as it is, x derivative is 1. So, here y square is as it is. It is like number 4, 2 square you feel. That is 4. It is like 4x. So, only 4 comes. Only y square comes now. Derivative of x is 1 plus. Next. This y cube is like the number 8 I have written earlier. So, it is a pure constant. There is no x in that one. So, for the pure constant, you have derivative 0. And z and t are both constants. So, z into t is also a constant. So, it is a pure constant. There is no x mixed in that one. So, the derivative will be 0. Finally, it is 3x square plus y square. You need to be clear about these two terms. Here it is a constant, but constant is along with the variable, so constant is taken outside. But it is a pure constant, so the derivative becomes a 0. What is the meaning of dou f by dou x? Derivative of f partially with respect to x. Partially means only one part x is variable, remaining all parts are constant. So please copy. What is the topic we are dealing right now? Very good. Partial. In this one, the concept of differentiation, whatever we used, same rules, sum rule, product rule, chain rule, everything is same, even the list continues same, only the concept is that we will treat only one as variable and remaining all variables as constants. Okay. Now, what is dou y of sine of xy? Then it is partial derivative of this function with respect to y. Then same rules of differentiation. So when sine comes, we will be taking cos. So what comes now? Cos of xy. Then comes the derivative of xy, but with respect to y. So with respect to y, what is constant? X is constant. So x is kept as it is. Y derivative is 1. We are talking with xy. So forget about everything. Just you are dealing with xy. In xy, x is constant. Derivative of y is 1. So finally it's how much now? That x comes out, x into cos xy. Copy this. Now let us do some more problems on this one. What is the partial derivative with respect to y for e to the power of x into y square sine xy plus y cube plus y square or xy square? So first basically it is a sum of 3 terms. So I'll split it like dou by dou y of e to the power of x y square sine xy. This gets finished plus dou by dou y. Don't write it as d by dy, you write it as dou by dou y of y cube plus dou by dou y of x y square Clear about this part? Okay. What about this one? Let us handle that first. With respect to y, x is constant. It is like 4y square, 5y square, 10y square. So it is xy square. So if it is 4y square, 4 will be kept as it is. Because it is xy square with respect to y, that x is constant, that x is kept as it is. And we have 2y for this one. What about this one? It is dou by dou y or d by dy. That is the same because there is only one variable is involved. It is to say that y is variable, and of course y is variable here getting used. So whether you say dou by dou y or d by dy, one and the same. So it will be nothing but 3y square plus. Now we need to handle this one. Here you see e power x is constant. It is in terms of y. Also this is in terms of y. Y is involved. So there are two functions involving y. So what I now do is e power x, I will take it outside. I will write dou by dou y of y square into sine of xy, this one. Is this point clear? Just I have taken e power x outside. Now that is equal to e to the power of x into. Is it getting covered up to here? Okay, good. Now this plus this one. Shall I remove this space and edit? No need, no? Let it be like this blank space. Okay. Now it is like one function into another function. It is like f into g. F into g. Don't make it as d by dy. It is dou by dou y. So what shall we do? Same rules of differentiation. No special rules separately for that. Partial differentiation. Except this small change. We are treating only one as variable, remaining all as constants. So come on, tell me. First I will copy y square as it is. And I will do differentiation for sin xy. Sin something that is cos something. Same thing, not something. Sin something derivative is not cos something. Sin of something derivative is cos of same thing. Sin something derivative is cos same thing. So xy. So what now? Cos xy into, as per chain rule we are doing now. Chain rule for this sin xy. Sin xy became cos xy into, with respect to y, x is constant. X is constant. Y derivative is 1. So this much of the part is the derivative for sin xy. Then what I need to do? Plus sin xy will be as it is, and I then do the differentiation of y square. That is nothing but 2y. So it's better to write that 2y in the beginning. So this complete is finished. Y square into this plus this into y square derivative. That's over. So up to where we have done, up to this. Then this will copy as it is, plus 3y square plus 2xy. I hope you understood. Copy this. One very important point, when we deal with some rules of some level, then whatever rules are there of previous levels, they will be coming sometimes in between. It is not that all the problems will be of one level appearing at one level. For example, you have x plus y by x square minus y square. This complete, you want the partial derivative with respect to x. Then don't think that x is available at two places and this x cannot be cancelled because it is x and x square here. So we need quotient rule. No need. Good. Very good. So that is not straightforward appearing it. But in previous level you know that x square minus y square can be written as x minus y into x plus y. And it is x plus y. Then this x plus y gets cancelled. We are left over with 1 by x minus 1. 1 by x minus y. We are doing differentiation with respect to what? With respect to x. We can write it as dou by dou x of x minus y whole power minus 1. You need to treat only x as a variable. What is y? Y is a constant. Can you treat it like x minus 10 instead of y? I am taking 10. So x minus 10 whole power minus 1. That is so simple. How do you do? I mean to say d by dx of x minus 10 whole power minus 1. What it will be? Minus 1 into x minus 10 whole power minus 2 into derivative of x minus 10 with respect to x, that is 1. It is like something power minus 1, that something we have dealt. Again we have done the differentiation for this x minus 10 with respect to x, it is 1. Now you can write in another step minus 1 by x minus 10 whole square. Once you know this concept is exactly same here because it is in x, y is treated constant. Dou by dou x means y is treated constant. So what will be the value of this one? That is minus 1 into x minus y whole to the power of minus 2 into derivative of x minus y with respect to x. Derivative of x is 1 minus derivative of y is 0 with respect to x, y is constant, pure constant. So it will be equal to 1 into minus 1, that is minus 1. So minus 1 by x minus y whole square. So if you don't cancel it, if you continue in that same product rule, quotient rule, you will get the same result. There is no doubt about it. It was not the only way. You will get the same. But the thing is, if you take the background knowledge into the use, you will be having advantage surely. I hope you understood. Okay.